from C, we see the first time where we have numbers inside of the x squared and inside of the y squared. We still know we have a hyperbola though. Why? Because we have a minus sign between the x squared and y squared. So it is a hyperbola. Now, where's the center? Well, we have to look at what's inside with the x and what's inside with the y. Remember, it's going to be reverse of what you see inside those parentheses. So we see a plus 6, so we're actually going to have a minus 6 as part of our center for the x coordinate. We see a plus 4 with the y, so we're actually going to have the reverse. We're going to have a negative 4 as our y. So that means it was actually shifted to the left 6 and down 4. Now, just like the last couple, notice what came first is x came first. What does that mean? Well, it means that x is our major axis. It means our hyperbola will, again, just like the last two, shoot out on the left and the right-hand sides. It also means that our a, which is always on the major axis, is going to come from the 144. It's already squared, though. So it means that a is actually going to be 12. And b is on the minor axis, and again, it's already squared. So if b is already squared, it means that b is actually 9. And again, if I've got a and b, I might as well go ahead and get used to finding c, which for hyperbola, the hyperbola has a minus, so it's not going to be the same. It's going to be the opposite. It's going to be a plus. Is c squared equals a squared plus b squared. And again, we said a from the major axis was 12, so 12 squared is 144. B was the 9 squared, which is 81. 9 squared, which is 81. Now we can go ahead and add our a squared plus b squared, so 144 plus 81, which is 225. As a warning, that is our c squared, not our c. We still have to find c by taking the square root of both sides of the equation. Luckily, the square root of 225 is a nice number, though. It is exactly 15. So now we have A, B, and C. Okay, how do we start our graph? Well, first of all, we have to draw our center, which was, according to what we found, -6, -4. So there's our center on our picture, -6, -4. Okay, now what? Okay, to do the vertices, remember we use the A. We're going to go left and right by our A, which was 12, from, though, the center. Well, the center was at -6, -4. So if we go to the left from -6, 12, we're going to sit at -18. So that's where we'll be, at -18. We're still at -4 because we haven't gone up or down. That's our first vertex. That is at -18, 4. The second vertex is going to have us do the other end, adding 12 to where our center was. Our center was again at -6, so adding 12 will put us at a +6. Again, we didn't go up or down. It's still at -4. So our second vertex is at 6, +6, -4. Okay, how do I find my foci? Well, our foci is all based on C. Well, C we found out was 15. So what we need to do is we need to add and subtract 15, again, along the major axis, which is along the X, from the center. So remember, the center for the X's was at -6. So we're going to add and subtract 15 to get the focus. So if we subtract 15 from that -6, we get -21. So we get negative 21 for that focus. We're still at negative 4 because we haven't gone left or right. The other focus is going to have you take that negative 6 and add 15. Well, negative 6 added to 15, added with the 15 will give us 9. And again, it's still at negative 4 because we haven't gone up or down. So all we did to find those foci at negative 21, negative 4, and 9, negative 4, was adding and subtracting that C of 15 to the vertex, which was at a vertex of negative 6 on the x-axis and negative 4 on the y. So again, the y's don't change because we're moving left and right because x was our major axis. Now be careful. Let's come up with our equation for our asymptotes. Remember, it should be rise over run. Well, rise is your y values. That comes from your b on this one. B is what's underneath your y, so that should be a 9, because that's your rise, over your run, which is your x's. That was what's underneath it's your radius for your x's, which is what's underneath your x squared, which was 12. So yes, there is again an issue that we had last time, which is your slope is 9 over 12, just like any normal slope. You'd reduce 9 over 12 to 3/4. And just like before, where was your center? Your center, as a reminder, was at negative 6, negative 4. Well, remember, your negative 6 is going to go inside of your parentheses with the x, so it goes in opposite, so it'll be a plus 6. The minus 4, whatever's going on with the y values, the shift up and down is going to be on the outside, so it will stay the same, so the minus 4 stays on the outside. The plus 6 is the opposite and stays on the inside. Okay, so you can leave your equations like that. You don't need to distribute. And again, the key thing to not forget is that plus or minus symbol out in front. Why? Because there should be two asymptotes that basically go through the same center, the negative 6, negative 4, but one has a positive slope and one has a negative slope. Now, if you want to quickly draw them, we already have the center drawn in at negative 6, negative 4 here. So if we want to actually draw in the asymptotes quickly, assume they weren't here already, we would use our box method. Well, our box method would say, from the center, let's make our box going. Well, the 9 tells us that we would go up and down on the y-axis, 9 from the center. So we were at, let's see, negative 4. So going up 9 would put us right at around, what? Going up 9 would put us right around 5. And going down 9 would put us, if we were at negative 4, right around negative 13. And doing the left-right part for the rest of the box would have to do with going left and right by 12. From where you were at the center was at negative 6, so that would take you all the way out to the 18, the negative 18, and the positive 6 where your vertices are. And that would create your box here so that you could draw your asymptotes. Remember, your asymptotes would then, once you have your box, go through the center and would go through each, making a diagonal through each corner of the box that you just made. Okay, we're still assuming that you have not actually drawn your parabolas. You do have your vertexes drawn at this point, so your hyperbola would shoot out from these two vertices getting towards your asymptotes on either end that you just now drew. But you can't actually draw your hyperbola until the very end when you've already got your asymptotes drawn. So you know what to get closer to, but to not actually touch.